China as well. At the Typhoon Committee meeting last January, there was a special lecture was given by someone who did modeling of the flow interaction of Morakot and this monsoon flow. So the key thing which was emphasized, here's part one, the southwesterly flow, and it was mentioned in the previous talk, this interaction, this convergence along this line. This is a modeling study, not an observational study. And what they did then is say that it's that convergence between the monsoon flow and the typhoon flow that led to the, and as was mentioned in the previous talk, the additional lifting on the central mountain range, which led to the disaster. So what they did was, I'm not sure how they did this, but what they did is run the control model, which is this one, and then they cut the water vapor from the east, and that didn't have much effect on the precipitation maximum. They cut the water vapor from the west, that didn't have much of an effect, and they cut the water vapor from the north and from the south. But when they cut the water vapor, this one here, this last diagram, it's whenever you cut that water vapor flow from the southwest that you have this significant effect removed, and therefore much less precipitation. So again, it just emphasizes this interaction between the typhoon. You've got to get on multiple scales here. We've talked about typhoons or tropical cyclones in general being a multi-scale interaction between the environment, the synoptic scale, the mesoscale, the convective scale, down to the boundary layer scale. But now we're talking about a much larger environmental influence when we talk about the monsoon. Another presentation which the Second International Workshop on Tropical Cyclones that I think could be very relevant here as you do your research, and that is, what is the model verification techniques? In the past, we've done things, and here's one of our examples in a hurricane, and they did swath-based precipitation verification. And so, you do the mean, the volume, and so forth all along the swath. Well, in evaluating models, and maybe Rob Rogers will talk more about this, one of the other ways of doing model verification in these cases is spatial forecasting. So this is from a presentation by Barbara Brown. And so things like precipitation and so forth, if you account for uncertainties in timing and location, in many cases the mesoscale thing can be in a slightly wrong position and score very poorly in a traditional verification technique. So by doing it spatially, you may be able to characterize the error in physical terms. It's a useful diagnostic for the model, and it's meaningful for the forecaster to know that the event was predicted, it just was in the wrong location or wrong timing. So there are various ways of doing the spatial verification, the neighborhood technique, the spatial separation, a little bit about what's in the previous talk, how it's displaced, the field deformation, or different techniques in terms of spatial variability. So you can do this for the case of important things such as phase error for the whole field. How should the forecast be adjusted to make the best use of the forecast? You can decompose the thing, sort of thing, by the different scales that we just heard in the previous talk. You can do neighborhood verification so that the model forecast could be good. It's just, it was in the neighborhood but not in the right location. And then object-based and feature-based techniques. So what Barbara Brown and her team is working on with the Hurricane Forecast Improvement Project, and this is what Rob Rogers will probably talk about, is ways of doing this with spatial techniques. So their particular technique is called MODE, Method for Objective-based or Object-based Diagnostic Evaluation. And this is freely available. This is being distributed freely, And so this is something you may want to consider here in Taiwan using it. So that you identify objects, you identify some attributes of whatever you're trying to forecast, you match the forecast attributes, especially important when you're comparing, intercomparing models, and then measure the differences between them. So the specific application is where the specific rainfall, instead of the swath, for example, in this particular example of Hurricane Rita, you'd want to, on this day, this is the feature that you'd be most interested in. On this day, you'd be most interested in how are the models verifying in this area, and then on the 25th of September, you want to verify that specific thing. How are the models forecasting this? What do we need to do to improve these localized maxima of heavy precipitation? So that's a matter of verification techniques. This is ongoing work, as I said, with HBIP. And so, how can we adapt those models for tropical cyclone? I think the big issue is how do you disentangle the errors due to the track forecast versus the physics forecast or the initial condition contributions to the errors. The other thing I'm going to talk about at the end is predictability, and as I mentioned in my comments earlier, a big thing is the interaction with the hydrological forecast. So this came from Zhenpeng Liu, who works at the Typhoon Committee Secretariat in Macau. And I think it's, I'm going to emphasize what are the meteorological requirements, but this just gives you some background on what the hydrologists do. And, flood control, drought relief. I didn't realize last year that Taiwan was in a drought. If it wouldn't have been for Morakot, it'd be even worse. But this is the hydrological problem. What's the meteorological input? What do they want from us? Well, rain gauges, obviously, radar, nowcasts, essentially, precipitation estimates from satellite. Then they have to know what the stream flow is doing. And then the key thing that we're to give to them in terms of forecasting is weather forecasts. I'm not going to cover these. I don't think snowpack's a big thing here. So they take this, river and flood warnings, flash flood, and what are the requirements that are necessary from us meteorologists in order to do this. So for flood forecasting, what they're asking for is lead times of 3 days for certain rivers